And I omitted the proof of this proposition. We have this definition of derivative. Okay, suppose g from I to R is a function defined on an open interval I of R and B belong to I. The derivative of g at B, denoted by this, is defined by this limit g prime of B equal to the limit of this fraction, okay, gb plus t minus gb divided to t tend to 0. If the limit above exists, in which case g is called differentiable at B, okay, because maybe this limit not exists, okay. If this limit exists, then we denoted this limit by g prime of B and call it g a differentiable function at B. A differentiable function at B, okay. And you know this definition, and you saw already this definition, but we have the fundamental theorem of calculus. Suppose f belongs to L1 of R, or equivalently f be an integrable function on R, okay. Define g from R to R by this equality, g of x equal to this integral of f. And suppose B belongs to R and f is continuous at B, then g is differentiable at B and g prime of B equal to f of B, okay. If B is a real number such that f is continuous at B, then g is differentiable at B. This g is differentiable at B. And the derivative of g at B equal to f of B. This is fundamental theorem of calculus, that you know this theorem, and its proof is easy because for each t non-equal 0, we have g of B plus t minus g of B divided by t minus f of B equal to this by the definition of g, because g of x equal to this integral, okay. So that g of B plus t equal to this integral, and x must be replaced by B plus t, and g of B equal to this by this definition again, and this equal to this integral, because we can write this, the integral of B up to the minus infinity, okay, because we know that please. Okay, I can write in this board, for example. Okay, please let me a minute, please. Let me. Excuse me, dear students, do you have my voice? Welcome, Murtaza, Mr. Mashadi. Dear students, do you have my voice? هل لديك صوتي؟
عندك صوت.
I saw that this integral, we know that the integral in this interval equal to minus this integral, okay? For each a and b, in this interval, so that we can replace this by the integral of f on b up to the minus infinity, and we have this b minus infinity and then minus infinity to this equal to this integral. And also we can write f of b equal to this integral, the integral of f of b on this interval dx, for example, okay, because this is a constant real number, so that this is equal to this, okay, b plus t dx, and this is equal to f of b multiplied by this b plus t minus b, and this is equal to t multiplied by f of b, okay, so that let me omit this, so that this integral equal to this, so that f of b equal to this integral divided by t equal to f of b. And we can replace this by this integral This shows that integral of f of x, for example, from b up to b plus t minus f of b equal to this fraction divided by t minus this fraction f of b d is divided by t, okay, and we can write this by this integral of b plus t f of x minus f of b is constant, okay, so that we have this integral. And if we consider for example, if we consider the supremum of this the supremum of this function on this interval by m, for example, Okay, if we consider, for example, m equal to this supremum, x belong to this interval, x minus b less than or equal absolute value of t. Okay, so that m is this interval, b minus this, t, and b plus t. Okay, so that we can see that this integral is less than or equal in this integral divided by this. And this values is less than or equal m, so that this is less than or equal this integral m dx divided by this. And this is less than or equal m. Okay, because this is equal m multiplied by t. Okay, this integral equal to a multiplied by b plus t minus p. Okay, so that this is less than or equal m. That we see that in this. We denoted this by m, for example. Okay, now for each epsilon by continuity of b at b, because we assume that f is continuous at b, so that for each epsilon we can choose t sufficiently small such that this is less than epsilon. Okay, for each epsilon there exists one delta positive number. Whenever if we have this, then f of x minus f of p is less than epsilon. So that if we consider delta sufficiently small such that we have in this interval such as this. Okay, then the subtraction is less than epsilon for each x, so that we can consider this less than epsilon. Okay, and we have the second version of Lebesgue differentiation theorem. Suppose f belongs to L1 of R, define G from R to R by this equality again. Then we have this equality G prime of B equal to f of B for almost every B. For almost every B. Maybe f be continuous at B or not, okay? Suppose T is a non-zero real number, then by this proposition that we don't present its proof, we have this, and G of B plus T equal to the integral of f minus infinity to B plus T, and also this, it is this integral from minus infinity to B, and this subtraction equal to this integral, and also we can this f of B such as this equal to this, okay? So that we have this inequality again, and by theorem 4.10, this converges to 0 for almost every B in R, so that this converges to 0 for almost B in R. You see theorem that we don't have this proof, okay? This equality holds for almost every B, so that this is 10 to 0 for almost every B, so that this is 10 to 0 for almost everywhere, every B in R. And we have this proposition that I omit its proof again. There does not, only please you see this proposition that there does not exist a Lebesgue measurable set as a subset of this interval, such that we have this equality for all B, okay? For all B. And we can read this proof. Suppose there does exist a Lebesgue measurable subset of 0, 1 with this property. For all B we have this equality. Then if we define G from R to R by this equality, then we see that G of B equal to b divided by 2 for all b in this interval. Because A is a subset of this interval, and if we have B in this interval, then the limit measure of this set equal to this, because this integral g of p okay, g of b equal to this integral, and this is equal to integral on whole of R phi of this set. Because B belongs to this interval, okay? And this is equal to the Lebesgue measure of this. Or by the Buch notation, we can see this. These two are the same, okay? The Lebesgue measure of this set. And this is equal to b divided by 2 by our assumption, by this assumption, okay? So that g of p equal to this, and hence this holds for all v, so that g prime of p equal to 1 over 2 for all b, okay? G prime of p equal to 1 divided by 2. The Lebesgue differentiation theorem implies that G prime of b equal to CE of b, because this is our f, function f, okay? For almost every b. However, this characteristic function never take on the value 1 over 2, because the value of this function is only 0 or 1, okay? The value of this function is 0 or 1, not this real number, which is a contradiction. And so we don't have any measurable subset of this interval by this property for all B. Okay. And also we have this proposition or theorem L1 of R function equal its local average almost everywhere. More precisely, suppose f is an integrable function on R, then for almost every B in R we have this equality. For almost every B we have this equality. It's proof for each t positive real number we have this equal to this. Because again f of b or this integral b minus t b plus t f of b, for example dx divided by 2t equal to, because this is a constant, this is equal to f of b multiplied by this integral okay. And this is equal to f of b plus t minus b minus t, so that this multiplied by 2t, okay, divided by 2t, and this is equal to f of b. This t is not in power, okay. 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 So that we can write instead of f of b equal to this integral, and then these two integral can be written as this, and this is less than this integral, and this tend to 0 by the first version of the Lebesgue differentiation theorem, okay. Dear students, do you have any problem? Do you have my voice? And do you see the image? Okay, thank you, sir. This is the definition of density. Suppose E is be a subset of R, the density of E at a number B is this limit if this limit exists. Otherwise, the density of E at B is undefined, okay. Is this limit exists, the value of this limit called the density of E at B. For example, as an example, please note that the density of whole of R equal to 1, and this is great density because density of R equal to this limit. The Lebesgue measure of R intersection by this, okay? Lebesgue measure intersected by this or lambda R intersection by the density of R in each element or each real number, okay? B minus T, B plus T divided by 2T, T tend to 0, and this is equal to, sorry, this is equal to the Lebesgue measure of this open interval divided by 2T, T tend to 0, because this is a subset of R, okay? This is whole of R, so that this intersection equal to this, and the Lebesgue measure of this interval equal to B plus T minus B minus T. And this is equal to this limit, and this is equal to 1, okay? So that R have the greatest density, or for example empty set have density 0, okay? Empty set have density 0 because if we replace this by empty, this set must be empty, and the Lebesgue measure of empty set equal to 0, so that this limit equal to 0, okay? The density of R in each point equal to 1, and the density of empty set in each element of R equal to 0, okay? Interval, density of 0B at B. If B belong to 0, 1, please note that. Let B belong to this interval, then density of zero one at B equal to this limit, okay? Zero one intersect by B minus T, B plus T divided by 2T, T tend to 0. And we see that we have this as our set E, and B is a set in this interval, so that if T tend to 0 for arbitrary small t, this is B minus T and this is B plus T, so that this is equal to this limit lambda of B minus T, B plus T divided by 2T, T tend to 0, and this is similar to the previous example, limit 2T divided by 2T, T tend to 0, and this is equal to 1. So that you see that for each B in this interval, the density of 0, 1 equal to 1, and other cases such as this you can check these cases, okay? But we have this theorem, Lebesgue density theorem. Suppose E be a subset of R, that is Lebesgue measurable set, then the density of E is 1 at almost every element of E and is 0 at almost every element in the complement of E, okay? So that we have this. Lambda of the set of all X in E such that density of E at X not equal 1 equal to 0. This means that the density of almost all element of E, okay, the density of E is 1 at almost every element, okay. This means that the set of all x that have density non-equal 1 have the measure 0, and also the density of all x in the complement of R, such that density of A at x not equal 0 equal to 0. Please read this proof and write it for me as an exercise. This proof is not difficult and not long, okay? You can read this proof easily. Okay.
فيما قراءة دليل هذه النظرية بالكامل وإرسالها إلينا مع التفاصيل الكاملة. فيما قراءة دليل هذه النظرية.
Do you understand? Dear students, do you understand this conversation? هل فهمتم؟ And we have this proposition. There exists a Borel set such as E, such that we have these inequalities. The Lebesgue measure of this intersection is strictly less than the Lebesgue measure of I, and this is strictly positive for every non-empty bounded open interval. And we omitted the proof of this again. Okay, we omitted the proof of this. For you, let me write. سأزيل دليل هذه القضية. Okay?
سأزيل دليل هذه القضية.
Okay? Do you understand? So that you must read the proof of the previous theorem, Lebesgue density, but I omit the proof of this. So we can excuse me, we can express in the Next session, product measures. Okay, and this is very important topics in measure theory, and I must choose some exercises that you solve and send to me, such as the previous sessions. Okay.
أحتاج إلى تحديد التمارين التي تحلها وترسلها إلي مثل الفصل الدراسي السابق.
Okay, do you understand? It is clear? Dear students, do you understand? I repeat this.
أحتاج إلى تحديد التمارين التي تحلها وترسلها إلي مثل الفصل الدراسي السابق.
Only Muhammad. Other students, do you understand? Abdul Salam, Ghassan, Leila, do you understand? Abdul Salam only raised his hand. Abdul Salam, do you have any questions? Okay. Thank you. And okay. And I apologize for my delation for some practices that you send to me and I don't send the correction of it for you, okay?
التأكيد التي أرسلتها لي سابقا. كذلك من تأخيري. مشغول جدا هذه الأيام. لكنني بالتأكيد سأقرأ كل تمارين كزمنية.
Okay, do you understand, dear students? Do you have any questions? Do you have any questions? Okay, thank you and goodbye. Thank you. Goodbye.